Okay, so we're looking to find the prime factorization of this 1 times 2 times 3 all the way to 9. Okay, so first let's write out the prime numbers, a few of them. 2, 3, 5, 7, and that's as far as we need to go because the next one's 11 and it's bigger than what we have here. Okay, so I'm going to first of all ignore the 1 because it's not included in prime factorization. It's not prime. So it's just gonna get tossed aside. For the rest of the numbers, I'm either gonna write down what they are if they are prime, or I'm gonna split them up into their prime factorization. So 2 is prime, I don't need to do anything with it. 3 is prime, I don't need to do anything with it. 4 is not prime, but it is 2 times 2, or 2 to the 2 power. Okay, 5 is prime. 6 is 2 times 3. 7 is prime. 8 is 2 to the 3rd power, and 9 is 3 to the 2 power. Okay, so now I'm going to gather all my 2's. I got 2, 2 squared, another 2, a 2 cubed, so I add all those up. So that's 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th power is our first factor. And then the 3's, it looks like we have a 3 here, 1, 2, 3, 4. 3 to the 4th. Okay, and then 5, we've only got the one of those, and 7, we've only got the one of those. That's it. That's your prime factorization. Let's do another one. Let's say we have, we'll call it B. For B, let's say that we have 33 to the 5th times 39 times 4 to the 12th. Okay, so let's split each one of these up into their prime factorization. So ignore the exponents for the time being and just look at the number. 33 can be split up into what? Well, it's divisible by 3. 3 times 11, which is also prime. So 3 times 11 gives us 33. So since 3 times 11 is equal to 33, then we're going to say that 3 to the 5th times 11 to the 5th is the same thing as 33 to the 5th. Okay. Likewise, with 39, let's split it up into its prime factorization. It is also divisible by 3. 3 times 13. 13 is also prime. Okay, so that's prime factorization there. And then 4 to the 12th, but 4 is 2 squared, right? So 2 squared to the 12th power. Now, we can say, okay, 2 squared to the 12th power, when you have these exponents like this, the 2 and the 12, you multiply those. Okay, so that's going to be 2 times 12, which is 2 to the 24th power. Okay, so cross that out and say 2 to the 24th. Okay, now let's put them in order. 2 to the 24 comes first. There's no other 2's. We've got a 3 to the 5th and a 3. That's 3 to the 6th. I added them up. And we've got an 11 to the 5th and a 13. And that is your prime factorization. Okay, how about this one? For C, let's say that I have 173. Okay, that's the only number I have. We want to split it up into prime factorization. Okay, so if you take the square root of 173, what do you get? Well, the square root of 173 is equal to about 13.153, and we'll put the dot, dot, dot on the end. Okay, so what that means is that we can list out the primes. We don't have to get any bigger than 13. Okay, if 13 times 13 is less than 173, but barely, then we don't need to go past that. So let's write out the primes. We have 2, 3, 5, 7, 11, 13. Okay, those are the numbers we need to try. Okay, so let's start with 2. Does 2 go into 173? It does not, because this is not even. Okay, so 2's off the list. Does 3 go in there? Okay, well, you could try dividing 3 into 173, and you could also use the trick that, well, let me tell you in a second. So this would be 5, 15, drop your 23, goes in there 7 times with a 2 remainder. It does not go in. And a quicker way of doing that, if you don't want to do it that way and you don't have a calculator, is just add your digits up. Okay, 7 plus 3 plus 1 is 11. 3 doesn't go into 11. So 3 doesn't go into 173. 5 doesn't go in because it doesn't this number doesn't end in a 5 or 0. So 5's out. 7. 7 into 173. Okay, that's 2, 14, 33. Does 7 go into 33 evenly? No, it does not. 7 times 5 is 35. So 7's off the list. Okay, let's do 11. So 11 into 173. 1 time, 63 remainder. It looks like it goes in there 5 times. It's 55. 8 remainder. It doesn't go in evenly. Okay, so we can cross that off the list. And let's erase this. And one more division. We already know because of this over here that 13 doesn't go in evenly, because the square root of it is 13.153. So there's no way that 13 is going to go in evenly. But just in case, let's just look at it. So 1 time, drop 43. Does 13 go into 43? It does not. It goes 3 times 39, and that is a remainder of 4. So it doesn't go in. So what does that tell us? Well, that tells us that 173 is prime. 173 is prime, so the factorization is itself. Okay, let's do one last one. Say we have 1,000 to the 8th power. Okay, we'll ignore the 8 for a second. Let's start dividing the 1,000 into its prime factorization. So how many times does 2 go in? Okay, so if you divide by 2, you get 500. Divide by another 2, you get 250. Divide by another 2, you get 125. So times 125. Okay, so that's 2 to the 3rd. Okay, and then 5 goes into this 3 times. 5 goes in there, and you get 25. And then again, and you get 5, and again you get 1. So 2 times 2 times 2 times 5 times 5 times 5 times 5 is equal to 1,000. Okay, so that's 2 to the 3rd times 5 to the 3rd is equal to 1,000. But we want 1,000 to the 8th. Okay, so this is going to be 2 to the 3rd to the 8th times 5 to the 3rd to the 8th is equal to 1,000 to the 8th. Okay, remember multiply, so 2 to the 24 times 5 to the 24 is the same thing as 1,000 to the 8th. This is the prime factorization. And that's it.